In the last packet, we learned how to solve linear equations, and in this packet, we are going to continue with that skill and learn how to solve linear inequalities. Luckily, solving linear inequalities is very, very similar to solving equations. We use all the same steps, all the same algebraic properties, but there's one major exception. So the major exception when you're solving linear inequalities is to change the direction of your inequality sign if you multiply or divide by a negative number. And this is huge. This is the most common mistake that students make when solving linear inequalities. If you are unsure of what an inequality is similar to an equation, but instead of having an equal sign, you are going to have the greater than, less than, greater than or equal to, or less than or equal to symbol. So these are going to be your inequality symbols that tell you when you need to use this major rule. And again, these rules or the steps to solving a linear inequality are the same exact steps that we've been using to solve equations. So you already know how to do this. You just have to remember to flip your sign if and only when you multiply or divide by a negative number. So let's go through some examples so you can see what I mean by that it's the same exact steps. So the first thing I'm going to do is draw a line down my inequality symbol. And this symbol is going to stay the same all the way down my path until I start multiplying and dividing. So on my left-hand side, I have a 167. That's going to stay the same. I don't have any like terms to combine. I don't have any distributing I need to do. On the right-hand side, I have 6 plus 7 times the quantity 2 minus 7x. So I can distribute this 7. So I'm going to drop down this 6 plus 7 times 2 is 14. 7 times negative 7x is negative 49x. I'm going to drop down my less than symbol and my 167. On my left-hand side, still nothing can be simplified. On my right-hand side, I have two constants. I have a positive 6 and a positive 14. So I'm going to combine those into 6 plus 14 is 20 minus 49x. Drop down my inequality sign. Drop down the 167. The 167 still cannot be simplified. 20 minus 49x cannot be simplified. So now I need to start moving things around. Remember that you want all of your numbers on one side, all of your variables on the other. So I have constants on the left, I have constants and variables on the right. So I'm going to move all my constants to the left. I have a positive 20, so I'm going to subtract 20 because the opposite of positive is negative, or the opposite of addition is subtraction. So I'm going to take this 20 minus 20. Property of equality, the subtraction property of equality tells me if I subtract something from the right, I must subtract it from the left. So I'm going to subtract 20 from the left-hand side. When I do that, 20 minus 20 zeroes out. 167 minus 20 is 147. Drop down my less than sign, negative 49x. Similar to when we were solving equations, my last step is going to be to divide. So I'm going to divide by a negative 49. Negative 49. And a little bell should be going off in your head because we read up here, if you multiply or divide by a negative number, you need to flip your sign. So when I grab my calculator, I'll be back. Gotta grab a calculator. I'm back. So when you grab your calculator and you do this division, we have 147 divided by negative 49, so 147 divided by, and the negative symbol is the symbol under the 3. So this is the negative symbol. If you use a subtraction sign, it's going to give you an error. So every time you're trying to type in a negative, make sure you're using this symbol here. So 147 divided by negative 49 gives me negative 3. So I have negative 3. I have to flip my inequality sign. So it was a less than sign. Now it's a greater than sign. Negative 49 cancels out negative 49. And I'm left with x. So negative 3 is greater than x, which is the same thing as saying x is less than negative 3. The mouth of your inequality, so whichever way that inequality is facing, has to say the same. So the negative 3 is where the mouth is. The negative 3 is where the mouth is. So these are interchangeable. It's the same answer. So you can check your answer by plugging in any number that is less than negative 3. So I'm going to plug in negative 5. Negative 5 is less than negative 3. And when I do that, I have 167 is less than 6 plus 7 times the quantity 2 minus 7 times negative 5, 265. Is 167 smaller than or less than 267? 265. 265. Yes, it is. 167 is less than 265. So I knew I did it correct. Example number 2. We are going to go through this example. It's a little bit less work than the previous example. I'm going to start off by drawing my line down my inequality sign. This time I have a less than or equal to. So I have y minus 6 is less than or equal to 18 plus 8y. Left-hand side cannot be simplified. I have y minus 6, so there's no like terms to combine. 18 plus 8y cannot be simplified. I have no like terms to combine over here. So I need to move all my variables to one side, all my numbers to the other. I'm going to move my variables to the left, my numbers to the right. So I'm going to start by subtracting 8y from both sides. I'm trying to get them onto the left-hand side, so I have to cancel out all the variables I have on the right-hand side. 8y and negative 8y, or positive 8y minus 8y, zeroes out, so all I'm left with is an 18. Drop down my symbol. Y minus 8y, 1y minus 8y, I have 1 minus 8, gives me negative 7, so I have negative 7y. Drop down my minus 6. So now I only have variables on the left. I need to only have numbers on the right. So I'm going to add 6 to the left, add 6 to the right. So I have negative 6 and positive 6, 0 out. Drop down my negative 7y, drop down my less than or equal to symbol. 18 plus 6, use my calculator, 18 plus 6, 24. My last step is to divide, so I'm going to divide by negative 7 because I just want y by itself. Divide by negative 7. That's going to cancel out here. Because I divided by a negative, my symbol's going to flip. So now, instead of having a less than or equal to sign, I have a greater than or equal to sign. And if I do 24 divided by 7, that's not going to give me an even number. That gives me 3.428, so I'm just going to say that's 3.4. You can get a decimal for your answer. If you get a decimal for your answer on a classwork assignment or on a test, I would double check your answer choices. If none of them are decimals, that means you made a small mistake. Or you can call me over and see if you're supposed to get decimals. So for this one, we got y is greater than 3.4 as our answer. Okay, let's do example number 3, and then we'll do some USA test prep examples. So example number 3, we have 3 times the quantity x minus 3 minus 5x is greater than negative 3x minus 6. So when I draw my line down my inequality symbol, the first thing I notice on the left-hand side is I can distribute. So I'm going to distribute this 3 just to what's inside the parentheses. I am not distributing to this negative 5x or this minus 5x because the 3 only contributes to what's inside the parentheses. So 3 times x is 3x. 3 times negative 3 is negative 9. And then I'm going to drop down my minus 5x. Keep my inequality symbol the same, so is greater than negative 3x minus 6. Checking my left-hand side to see if it can be simplified. It can. I see some like terms. I have a 3x and a minus 5x. So if I do 3 minus 5, I get negative 2. So on the left, I have negative 2x minus 9 is greater than 3x minus 6. So for me, I prefer to have my variables on the left-hand side, so I need to move this 3x over here. So to cancel out the 3x on the right, I'm going to subtract 3x from both sides. That zeroes out. Negative 2x minus 3x is negative 5x. Keep this minus 9 is greater than negative 6. I need to get this negative 9 onto this side. So to cancel out the negative 9, I'm going to add 9 to both sides. I'm going to move my work up here. So that zeroes out on the left. I'm left with negative 5x is greater than negative 6 plus 9, which is 3. Now I'm going to divide both sides by negative 5. When you do that, the negative 5 cancels out, so I'm left with x. I divided by a negative, so I need to flip my sign. And I'm going to leave this as a fraction. I'm going to leave it as negative 3 over 5. Because I know that 5 does not go into 3 evenly, I am going to leave it as a fraction. You do have that option. If you wanted to convert it to a decimal, negative 3 divided by 5, you would get negative 0.6. So either way, as a fraction or a decimal, we could have left this one up here, 24 over 7, or negative 24 over 7. You can leave it that way. Notice that I put the negative sign at the top rather than the bottom. Either way, it's correct. You just need to know that your answer is negative. So again, solving inequalities is the same as solving equations, but you have an inequality symbol, and that inequality symbol must be flipped if you multiply or divide by a negative number. We did not do an example of multiplying by a negative number. You are only going to see that if you have a fraction. We didn't have any fractions in here, so we didn't have to multiply by a negative number. Let's go through 2 examples of how you might see this on the milestone or on an exam. So number 1 is very similar to what we've been doing. It's to solve the inequality. So we need to solve this inequality using our steps. So I drew my line. Now I'm going to simplify. So I have 3m. I'm going to distribute this negative 3. I'm treating this like a negative 3 because it has a minus sign out in front of it. So negative 3 times m is negative 3m. Negative 3 times 8 is negative 24. Drop down my greater than symbol, 3m. I can simplify this left-hand side. 3m minus 3m is 0. So those cancel each other out, and I'm left with negative 24 is greater than 3m. To get this m by itself, I need to divide both sides by 3. Negative 24 divided by 3 is negative 8. Drop down the same inequality sign because this time I divided by a positive number. Whenever you divide by a positive number, your inequality symbol does not change. So I have negative 8 is greater than m, which can also be written as m is less than negative 8. Notice the mouth is pointing towards the negative 8. The mouth is pointing towards the negative 8. So I need to match this answer to over here, and it would give me answer choice D. Number 2 is very similar, but this time they want you to match it to a graph. So first I need to solve this inequality, so I'm going to draw my line. All of my x's are over here on the right, so I just need to move these constants to the left. Negative 5 plus 5 will cancel that out on the right. 5 plus 5 is 10, is less than or equal to 2x. Get the x by itself, I'm going to divide both sides by 2. I get 5 is less than or equal to x. So now we have to match this to a graph. And I'm going to write this with the x first. So I'm going to say x is greater than or equal to 5. So if we want numbers greater than or equal to 5, we want 5 or 6 or 7 or 8 and so forth. So we know our arrow needs to be pointing to the right because we want numbers bigger than 5. So I know these graphs are hard to read, but this one goes like this, like this, like this, and like this. So I could automatically cross out C